Picture this. You're an astronomer, scanning the dark expanse of space through your telescope, when suddenly you spot something extraordinary. An object moving through our solar system at a blistering 245,000 kilometers per hour, faster than anything we've ever detected before. But here's the twist. This isn't just any space rock. This visitor from another star system is displaying behavior so unusual, so precisely calculated, that a Harvard physicist is asking a question that might keep you awake at night. What if this isn't a natural object at all? What if we're witnessing our first encounter with alien technology? And what if it's conducting its own version of a Turing test on us? Welcome to the mind-bending case of 3I Atlas, an interstellar interloper that's forcing scientists to confront possibilities that sound more like science fiction than peer-reviewed astronomy. I'm about to take you on a journey through one of the most controversial scientific hypotheses of our time, where the line between natural phenomena and artificial intelligence becomes terrifyingly blurred. Now, before we dive into this cosmic mystery, I want you to know that what you're about to hear isn't accepted by the mainstream scientific community. In fact, most astronomers are calling it complete nonsense. But here's the thing about extraordinary claims. They deserve extraordinary investigation. And when that claim comes from Avi Loeb, the former chair of Harvard's astronomy department, a man who's published over 800 scientific papers and advised NASA on their search for extraterrestrial life, well, maybe it's worth our attention. So, settle in, because we're about to explore a hypothesis that could fundamentally change how we view our place in the universe. We'll examine the evidence, dissect the skepticism, and ask the uncomfortable question. If an alien civilization wanted to study us without revealing themselves, how exactly would they do it? Let me start by painting you a picture of just how extraordinary 3I Atlas really is. On July 1st, 2025, the Atlas Survey Telescope in Chile detected something unprecedented, an object roughly 7 miles wide, hurtling through space on a trajectory that defied everything we thought we knew about natural celestial mechanics. This wasn't just another asteroid or comet wandering through our cosmic neighborhood. This was something that had traveled across the vast emptiness between stars, a journey that takes millions of years, only to arrive at our solar system with a precision that would make a Swiss watchmaker weep. But here's where things get interesting. 3 Atlas isn't just passing through our solar system randomly. Its orbital path has an eccentricity of 6.2, which means it's moving on one of the most hyperbolic trajectories ever recorded. To put that in perspective, the first known interstellar visitor, the famous Oumuamua, had an eccentricity of 1.2. The second visitor, 2I Borisov, clocked in at 3.6. 3I Atlas is off the charts, literally. Now, you might be thinking, so what? Space is full of fast-moving objects with weird orbits. But here's the kicker, and this is where Avi Loeb's hypothesis starts to sound less crazy and more terrifying. The trajectory of 3I Atlas allows it to approach Venus, Mars, and Jupiter with a probability that astronomers calculate at less than 0.005%. In other words, the chances of a natural object randomly stumbling into such a perfect position to study our solar system's planets is essentially zero. Think about that for a moment. We're talking about an object that traveled across interstellar space, a journey of unimaginable distance and duration, only to arrive at our solar system with a trajectory that gives it optimal access to multiple planets. It's like throwing a dart from New York and hitting a bullseye in London. Except the dart had to travel for millions of years through a cosmic hurricane, but the astronomical improbabilities don't stop there. I Atlas has what's called a low retrograde tilt to the ecliptic plane, meaning its orbital path is almost perfectly aligned with the plane of our solar system. This alignment offers what Loeb and his colleagues describe as various benefits to an extraterrestrial intelligence, because it allows the object to access our planets with what they ominously call relative impunity. Now, I know what some of you are thinking. This sounds like the setup to a Hollywood blockbuster, not serious science. And you're not wrong to be skeptical. The the scientific community has been brutal in their criticism of Loeb's hypothesis. Chris Lintott, an astronomer at Oxford University, called the suggestion that 3I Atlas might be artificial nonsense on stilts. Samantha Lawler from the University of Regina pointed out that extraordinary claims require extraordinary evidence, and the evidence presented is absolutely not extraordinary. But here's what makes this more than just academic theatre. Loeb isn't some fringe theorist working out of his garage. This is a man who's spent decades studying the cosmos, who's advised governments on space policy, and who's published research that's shaped our understanding of black holes, cosmic inflation, and the early universe. When someone with those credentials stakes their reputation on a hypothesis this controversial, it's worth examining their reasoning. The core of Loeb's argument rests on what's known as the dark forest hypothesis, a solution to the famous Fermi paradox that asks, if the universe is so vast and old, where is everybody? The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that alien civilizations do exist, but they remain silent and hidden because the universe is essentially a cosmic battlefield, where revealing your location means certain destruction. According to this hypothesis, intelligent civilizations stay quiet, not because they're peaceful, but because they're terrified. They understand that in a universe where resources are finite and intentions are unknowable, the safest strategy is to eliminate potential threats before those threats can eliminate you. It's cosmic paranoia elevated to a survival strategy. Now, if you're an advanced civilization operating under dark forest principles, how would you gather intelligence about potential threats? You certainly wouldn't announce your presence with radio signals or massive spaceships. Instead, you might send reconnaissance probes designed to look like natural objects to study your targets without revealing your technological capabilities. You might, in other words, send something that looks exactly like 3I Atlas. This brings us to the Turing Test connection, and it's here that Loeb's hypothesis becomes truly fascinating. The original Turing Test, proposed by Alan Turing in 1950, was designed to determine whether a machine could think like a human. The test involved a human judge engaging in conversations with both a human and a machine, without knowing which was which. If the judge couldn't distinguish the machine from the human, the machine passed the test. But what if we flip this scenario? What if an alien civilization is conducting its own version of a Turing test on us? Instead of trying to convince us that their artificial intelligence is natural, they're trying to convince us that their artificial spacecraft is natural. The question becomes, can we distinguish between a natural interstellar object and an artificial one designed to mimic natural phenomena? This is where the case of 3I Atlas becomes genuinely unsettling. Every anomaly in its behavior could be explained as either a natural phenomenon we don't fully understand, or as evidence of sophisticated camouflage technology. Its unusual composition, showing water ice and hydroxide ions, could be the result of its formation around a low metallicity star, or it could be a deliberate choice to mimic what we'd expect from a natural comet. The timing of its approach is equally suspicious. Unlike Oumuamua, which was discovered after it had already passed its closest approach to the Sun, 3I Atlas was detected well before perihelion, giving us months to observe and study it. From our perspective, this seems like a stroke of scientific luck. But from the perspective of an intelligence-gathering mission, it's perfect timing. It allows maximum observation time while maintaining the cover of natural phenomena. Perhaps most intriguingly, 3I Atlas will be hidden behind the Sun from Earth's perspective during its closest approach in October 2025. Loeb and his colleagues point out that this solar eclipse would provide the perfect opportunity for what they call a clandestine reverse solar Oberth maneuver. This is a high-thrust strategy that would allow a spacecraft to use the Sun's gravity to brake and potentially remain bound to our solar system, all while hidden from Earth-based observation. The implications of this possibility are staggering. If 3i Atlas is indeed an artificial probe, then we're not just dealing with evidence of extraterrestrial intelligence. We're dealing with evidence of an intelligence that's actively studying us while taking elaborate precautions to remain undetected. It suggests a level of technological sophistication that makes our most advanced spacecraft look like stone tools. But it also raises uncomfortable questions about intentions. Why would an advanced civilization go to such lengths to study us in secret? The optimistic interpretation is scientific curiosity, a cosmic version of wildlife researchers studying animals in their natural habitat. The pessimistic interpretation, the one that keeps Loeb awake at night, is reconnaissance before invasion. Under the dark forest hypothesis, any civilization advanced enough to send interstellar probes would view emerging civilizations like ours as potential future threats. They might study us, not out of scientific curiosity, but to assess our technological trajectory and determine whether we pose a long-term danger to their survival. In this scenario, 3i Atlas isn't just gathering data about our solar system's planets, it's gathering data about us. The beauty and terror of Loeb's hypothesis is that it's testable. Science fiction becomes science when it makes falsifiable predictions, and that's exactly what this theory does. If 3i Atlas is indeed an artificial probe, it should exhibit behaviors that natural objects simply cannot. Specifically, it should perform maneuvers during its passage through our solar system that violate our understanding of celestial mechanics. The critical period, according to Loeb's calculations, will be between November 21st and December 5th, 2025. This is when 3i Atlas, if it is artificial, would be optimally positioned to conduct detailed observations of Earth. If the object performs any unexpected trajectory changes during this window, particularly ones that bring it closer to our planet, it would provide compelling evidence for the artificial hypothesis. But here's the terrifying part. If 3i Atlas does reveal itself to be artificial during this period, what happens next? Do we try to communicate? Do we prepare defenses? Do we hide and hope it goes away? We're potentially facing our first contact scenario, and we're completely unprepared for the possibility that first contact might not come in the form of a radio signal, but as a reconnaissance mission from a civilization that views the universe as a dark forest full of threats. The scientific community's hostile reaction to Loeb's hypothesis reveals something important about how we approach the search for extraterrestrial intelligence. We're comfortable looking for radio signals from distant civilizations, but we're deeply uncomfortable with the possibility that those civilizations might already be here, studying us. It's a cognitive bias that Loeb calls out directly. Why is it reasonable to search for alien techno-signatures in radio waves, but unreasonable to search for them among interstellar objects? This brings us back to the fundamental question. Are we alone, or are we being watched? 3i Atlas represents a test case for how seriously we take the possibility that we might not be the only intelligence in our cosmic neighborhood. It challenges us to expand our definition of what alien contact might look like and forces us to confront the uncomfortable possibility that we might be the subjects of study rather than the researchers. As 3i Atlas continues its journey through our solar system, picking up speed as it approaches the Sun, we're essentially waiting for the results of an alien Turing test. Either this object will behave exactly as a natural comet should, vindicating the skeptics and relegating Loeb's hypothesis to an interesting footnote in astronomical history, or it will reveal capabilities that no natural object should possess, fundamentally changing our understanding of our place in the universe. The clock is ticking, quite literally, as we approach what could be the most consequential period in human history. But while astronomers debate and theorists argue, 3i Atlas continues its relentless journey toward the inner solar system, indifferent to our speculation and seemingly oblivious to the storm of controversy swirling around its true nature. What makes this entire scenario even more fascinating is how it reflects our own psychological relationship with the unknown. We humans have a peculiar tendency to see patterns where none exist, to find meaning in randomness, and to project intelligence onto natural phenomena. It's called Paridolia, the same cognitive quirk that makes us see faces in clouds or hear voices in static. So when we encounter something as statistically improbable as 3I Atlas, our pattern-seeking brains immediately start connecting dots that might not actually be connected. But here's the uncomfortable truth. Sometimes the dots really are connected. Sometimes the pattern is real. Sometimes what looks like intelligence actually is intelligence. The challenge lies in distinguishing between wishful thinking and genuine discovery, between cosmic coincidence and cosmic contact. This brings us to one of the most intriguing aspects of Loeb's hypothesis, something that most critics have overlooked in their rush to debunk his claims. The theory doesn't just predict that 3I Atlas might be artificial. It predicts how an artificial object would behave, what capabilities it would need, and most importantly, what mistakes it might make that would reveal its true nature. Consider the reverse solar Oberth maneuver that Loeb describes. This is an incredibly sophisticated gravitational technique that would allow a spacecraft to use the sun's immense gravity well as a brake, converting its tremendous interstellar velocity into orbital energy. It's the kind of maneuver that requires not just advanced propulsion technology, but precise computational modeling of gravitational dynamics across multiple celestial bodies. No natural object could perform such a maneuver. Comets and asteroids don't make course corrections. They don't optimize their trajectories. They simply follow the laws of physics, falling along predictable paths determined by gravity and momentum. If 3I Atlas executes anything resembling a reverse solar Oberth maneuver, it would be smoking gun evidence of artificial origin. But the implications go deeper than just propulsion technology. The timing and positioning required for such a maneuver suggests something far more sophisticated than a simple reconnaissance probe. We're talking about an object that would need to understand not just our solar system's gravitational architecture, but our observational capabilities and limitations. It would need to know exactly when and where Earth-based telescopes could and couldn't observe it. This level of intelligence gathering implies long-term surveillance. You don't develop that kind of detailed knowledge overnight. It suggests that 3I Atlas, if artificial, might not be our first visitor. It might be part of an ongoing monitoring program that's been studying our solar system for far longer than we realize. The possibility becomes even more chilling when you consider the age estimates for 3I Atlas. Unlike the previous interstellar visitors, which appeared relatively young in cosmic terms, 3I Atlas shows characteristics suggesting it originated from the thick galactic disk, making it potentially older than our Sun. If this object is artificial, we're not dealing with technology from a recently emerged civilization. We're dealing with technology that might be billions of years old. Think about what that means. Human civilization is roughly 10,000 years old. Our industrial technology spans barely 300 years. We've had spaceflight for less than a century. Now imagine a civilization with a billion-year head start. Their technology would be so advanced that it might appear completely natural to us, indistinguishable from the fundamental forces of the universe itself. This is where the alien Turing test becomes truly terrifying. We're not just asking whether we can distinguish artificial from natural. We're asking whether we can distinguish artificial from what we think is natural, but might actually be artificial. How would we recognize technology that's evolved for a billion years? How would we detect intelligence that's had eons to perfect its camouflage? The answer might be, we wouldn't. At least not directly. But intelligence, no matter how advanced, leaves traces. It makes choices. It optimizes. And optimization, even perfect optimization, creates patterns that pure randomness cannot produce. The trajectory of 3I Atlas is one such pattern. Its timing is another. Its composition, its behavior, its apparent age, all of these create a constellation of characteristics that individually might be explained by natural processes, but collectively form a signature that's statistically impossible to ignore. Yet the scientific establishment continues to ignore it, and this resistance tells us something important about how science actually works. Despite our idealized image of scientists as objective seekers of truth, the reality is that science is also a social institution with its own biases, hierarchies, and taboos. The search for extraterrestrial intelligence has become respectable, even mainstream, but only when confined to certain approved methods. Radio telescopes scanning for signals, mathematical models of galactic colonization, philosophical discussions of the Fermi paradox, but suggest that aliens might already be here, that they might be studying us right now through technology so advanced we mistake it for natural phenomena, and suddenly you're beyond the pale of acceptable scientific discourse. You're a crank, a publicity seeker, a threat to the serious work of real astronomy. This institutional bias creates a fascinating paradox. The same scientific community that acknowledges the universe likely contains billions of intelligent civilizations becomes deeply uncomfortable when confronted with evidence that one of those civilizations might have found us first. It's as if we're psychologically prepared for the idea of aliens existing somewhere else, but completely unprepared for the possibility that they might exist here. Loeb's willingness to challenge this bias has made him a controversial figure, but it's also made him something more important, a test case for how seriously we take our own stated beliefs about extraterrestrial intelligence. If we truly believe the universe is teeming with intelligent life, then we should also believe that some of that life might be more advanced than us, and that advanced civilizations would have both the capability and the motivation to study emerging species like ourselves. The question becomes, are we brave enough to face that possibility? Or do we prefer the comfortable fiction that we're alone until proven otherwise? As 3I Atlas continues its approach toward perihelion, we're essentially conducting a real-time experiment in scientific courage. Every day brings new observational data, new measurements of trajectory and composition, new opportunities to detect the subtle signatures that might reveal artificial origin. The object is becoming brighter as it approaches the sun, making it easier to study, but also more active as solar radiation begins to sublime its surface materials. This increased activity is crucial for testing Loeb's hypothesis. Natural comets become more active as they near the sun because solar energy vaporizes their icy components, creating the characteristic coma and tail that make comets visible from Earth. But if 3I Atlas is artificial, its apparent cometary activity might be carefully engineered camouflage, designed to make it look natural while concealing its true technological nature. The key will be in the details. Natural cometary activity follows predictable patterns based on solar heating, surface composition, and rotational dynamics. Artificial activity, designed to mimic natural processes, might follow those same general patterns, but would likely show subtle deviations, tiny inconsistencies that reveal the hand of intelligence behind the phenomena. These deviations might be incredibly subtle. A slight asymmetry in the coma formation, an unexpected variation in the emission spectrum, a rotational pattern that's too regular or too chaotic to be natural. The signatures of intelligence, if they exist, will likely be found not in dramatic maneuvers or obvious artificial structures, but in the tiny details that separate optimization from randomness. This is why the observational window for 3I Atlas is so crucial. Unlike previous interstellar visitors, which were discovered after their closest approach to the Sun, we have the unprecedented opportunity to study this object throughout its entire passage through our solar system. We can track its evolution from a distant, inactive object to an active comet, and potentially back to dormancy as it recedes toward interstellar space. But this observational opportunity comes with a time limit. Solar conjunction will hide 3I Atlas from Earth-based telescopes during its closest approach to the Sun, creating a crucial blind spot in our observations. From October through early December 2025, we won't be able to see what the object is doing. If it's going to reveal its artificial nature, that hidden period would be the perfect time to do it. The solar eclipse of 3I Atlas creates what intelligence analysts would call a window of opportunity. If this object is indeed an artificial probe, its controllers would know that Earth-based observers can't see behind the Sun. They could drop their camouflage, perform whatever maneuvers they need to complete their mission, and resume their natural disguise before emerging from solar conjunction. This possibility has prompted Loeb and his colleagues to propose using spacecraft already in the outer solar system to maintain observation during the eclipse period. The Juno probe, currently orbiting Jupiter, will be positioned to observe 3I Atlas when it passes within 53.6 million kilometers of the gas giant in March 2026. If the object shows any signs of artificial modification or unexpected behavior during this encounter, it could provide the smoking gun evidence that mainstream astronomy has been demanding. But even if 3I Atlas passes every test and behaves exactly like a natural comet should, Loeb's hypothesis will have served an important purpose. It will have forced us to develop the observational and analytical tools necessary to distinguish artificial from natural among interstellar visitors. Because whether or not 3I Atlas is artificial, it won't be the last object to visit our solar system from interstellar space. Recent surveys suggest that interstellar objects like 3I Atlas might be far more common than previously thought. The discovery of 3 such objects in less than a decade implies that dozens or even hundreds of similar visitors pass through our solar system undetected. If even a small percentage of these objects are artificial, we're looking at an ongoing program of surveillance that's been operating for potentially millions of years. This possibility fundamentally changes how we think about our place in the cosmic community. Instead of being isolated observers searching for signs of distant intelligence, we might be specimens in an ongoing study conducted by civilizations so advanced that their technology is literally indistinguishable from natural phenomena. We might be living inside someone else's laboratory, being watched and catalogued by intelligences that view us the same way we view bacteria in a petri dish. The implications extend far beyond astronomy into philosophy, theology, and the very foundations of human meaning and purpose. If we are being studied, what does that say about our significance in the universe? Are we important enough to merit detailed observation, or are we just another data point in a vast cosmic census? Are our watchers benevolent scientists gathering knowledge for its own sake, or are they strategic planners assessing potential threats and opportunities? These questions might seem premature given the current state of evidence, but they're worth considering because the answers will shape how we respond if and when 3I Atlas or a future visitor reveals its artificial nature. First contact, if it comes, might not arrive as a dramatic radio signal or a massive mothership appearing over major cities. It might come as the subtle revelation that something we thought was natural is actually artificial, that we've been under observation all along. The psychological impact of such a revelation would be profound. Humans are accustomed to being the observers, the researchers, the intelligence that studies and categorizes the natural world around us. The discovery that we ourselves are being observed and studied would represent a fundamental shift in our cosmic perspective, a humbling reminder that intelligence and technology extend far beyond the boundaries of human capability. But it would also represent an unprecedented opportunity. Contact with an intelligence advanced enough to conduct interstellar reconnaissance would offer possibilities for scientific and technological advancement that we can barely imagine. The question becomes, would such an advanced civilization be willing to reveal itself and share its knowledge, or would it prefer to maintain its observational distance, studying us like we study wildlife in nature preserves? The answer might depend on how we respond to the possibility itself. Our reaction to Loeb's hypothesis might be serving as its own kind of test, a measure of human readiness for contact with non-human intelligence. Are we mature enough as a species to handle the knowledge that we're not alone? Can we respond to evidence of superior intelligence with curiosity rather than fear, with scientific rigor rather than denial? The coming months will provide answers to these questions, whether we're ready for them or not. The behavior of 3I Atlas during these crucial observations will essentially determine whether we're witnessing the greatest natural coincidence in recorded history or something far more extraordinary. But here's where the story takes an even stranger turn, because the object's behavior so far has been anything but ordinary. Unlike typical comets that follow predictable patterns of activity as they approach the Sun, 3I Atlas has been displaying what astronomers politely call anomalous characteristics. Its brightness variations don't match standard models of cometary behavior. Its spectroscopic signature shows unexpected compounds at unexpected concentrations. Most puzzling of all, its trajectory has remained remarkably stable despite the gravitational influences it should be experiencing from multiple planetary bodies. Now, you might think these anomalies would generate excitement in the astronomical community. After all, isn't science supposed to thrive on the unexpected? But the reaction has been quite the opposite. Rather than investigating these peculiarities with the curiosity they deserve, most astronomers have chosen to either ignore them entirely or explain them away with increasingly elaborate natural mechanisms. This response reveals something troubling about how modern science approaches truly paradigm-shifting possibilities. We've become so invested in our current understanding of the universe that we're reluctant to seriously consider evidence that might overturn that understanding. It's easier to dismiss anomalous data than to confront the possibility that our fundamental assumptions about reality might be incomplete. But let's step back and consider what we're really dealing with here. Atlas isn't just displaying one or two unusual characteristics. It's displaying a constellation of anomalies that, when taken together, paint a picture that's almost impossible to reconcile with natural origin. The statistical probability of all these factors occurring together in a single natural object approaches zero. Consider the trajectory alone. The object's path through our solar system provides optimal viewing angles for studying Earth, Mars, Venus, and Jupiter. It arrives with perfect timing to conduct extended observations before disappearing behind the Sun during its most vulnerable period. It maintains a stable orientation that maximizes its observational capabilities while minimizing the risk of detection. These aren't just coincidences, they're optimizations. An optimization, as any engineer will tell you, is the signature of intelligence. Natural processes tend toward entropy, toward disorder and randomness. Intelligence moves in the opposite direction, creating order, efficiency, and purpose. When we see optimization in nature, we usually find intelligence behind it, whether it's the aerodynamic efficiency of a bird's wing shaped by evolutionary selection, or the mathematical precision of a spider's web optimized for prey capture. The optimization evident in 3I Atlas's behavior suggests something far more sophisticated than biological evolution. We're looking at engineering on a scale and with a precision that exceeds anything humans have achieved. If this object is artificial, its creators have mastered technologies that we're only beginning to imagine. The propulsion system alone would represent a revolution in physics. To accelerate an object the size of 3 Atlas to interstellar velocities requires energy sources that dwarf anything in our current technological arsenal. Nuclear fusion, our most advanced theoretical propulsion concept, couldn't even come close to providing the necessary power. We're talking about technologies that manipulate fundamental forces in ways we don't yet understand. But propulsion is just the beginning. The object's apparent ability to maintain its camouflage while conducting observations suggests information processing capabilities that would make our most advanced supercomputers look like pocket calculators. Real-time analysis of gravitational fields, solar radiation patterns, and observational windows from multiple planetary positions requires computational power on a scale we can barely comprehend. Then there's the materials science. Any object traveling through interstellar space for potentially millions of years would be subjected to radiation, micrometeorite bombardment, and temperature extremes that would destroy conventional spacecraft. The fact that 3I Atlas appears structurally intact suggests materials and construction techniques far beyond our current capabilities. These technological implications raise uncomfortable questions about human technological development. If civilizations capable of interstellar reconnaissance have been operating in our galaxy for millions or billions of years, what does that say about our own technological trajectory? Are we following a path that leads to similar capabilities, or are we fundamentally limited by our biology, our psychology, or our planetary resources? The answer might depend on how we handle the current situation. Our response to 3I Atlas could determine whether we're viewed as a species worth contacting, or one that should be left to develop in isolation. If we react with fear, aggression, or denial, we might convince any watching civilizations that we're not ready for contact. If we respond with curiosity, scientific rigor, and open-mindedness, we might demonstrate the kind of intellectual maturity that advanced civilizations look for in potential contact candidates. This brings us to one of the most fascinating aspects of Loeb's hypothesis. It's essentially reversing the traditional SETI paradigm. Instead of us searching for them, they might already be here, searching us. Instead of trying to prove we're intelligent enough to deserve contact, we might be taking a test we don't even realize we're taking. The implications for human behavior are profound. How do you act when you suspect you're being watched by an intelligence vastly superior to your own? Do you try to impress them with our achievements, or do you try to hide our flaws and conflicts? Do you attempt communication, or do you wait for them to make the first move? These questions become even more complex when you consider the dark forest hypothesis that underlies Loeb's thinking. If the universe is indeed a dangerous place where civilizations destroy each other to prevent future threats, then any contact scenario becomes fraught with existential risk. Revealing our capabilities might mark us for elimination. Hiding our capabilities might make us appear deceptive or primitive. The strategic implications are staggering. If 3I Atlas is conducting reconnaissance for a potentially hostile civilization, then our response to its presence could determine the future of human civilization. But if it's conducting peaceful scientific observation, then our response could determine whether we're invited into a galactic community of intelligent species. The challenge is that we have no way of knowing which scenario we're dealing with until it's potentially too late to change course. This uncertainty creates what game theorists call an information problem. We're required to make decisions with incomplete information about stakes we can barely comprehend. But perhaps that's exactly the point. Perhaps the test isn't about our technology or our intelligence, but about our wisdom. How do we respond to uncertainty? How do we balance caution with curiosity? How do we maintain our scientific integrity while acknowledging the possibility that everything we think we know might be wrong? These are the questions that 3I Atlas is forcing us to confront, whether we want to or not. The object doesn't care about our institutional biases, our academic hierarchies, or our comfortable assumptions about our place in the universe. It simply continues its relentless journey through our solar system, indifferent to our speculation, and seemingly unaware of the revolution it's causing in human thought. But here's what makes this entire scenario genuinely fascinating from a scientific perspective. It's forcing us to develop new methodologies for distinguishing artificial from natural phenomena. Traditional astronomy assumes that anything we observe in space is natural unless proven otherwise. But if advanced civilizations are capable of creating technology that mimics natural processes, then that assumption becomes not just wrong, but dangerously naive. We need new tools, new analytical frameworks, new ways of thinking about the data we collect from space-based observations. We need to develop what we might call xenoarchaeology, the ability to detect traces of non-human intelligence in astronomical data. This isn't just about looking for radio signals anymore. It's about recognizing the subtle signatures that advanced technology might leave in gravitational interactions, spectroscopic data, and orbital mechanics. The development of these new analytical tools will have implications far beyond the case of 3i Atlas. As our telescopes become more powerful and our detection capabilities more sophisticated, we're going to be observing more and more objects that don't fit neatly into our current categories of natural phenomena. Some of these will undoubtedly be natural objects that we simply don't understand yet. But others might be artificial objects so advanced that we've been mistaking them for natural phenomena all along. Consider the possibility that some of what we classify as asteroids, comets, or even small moons might actually be artificial constructs, millions or billions of years old. Consider the possibility that some of the gravitational anomalies we attribute to dark matter might actually be the signatures of advanced propulsion systems. Consider the possibility that some of the energy sources we observe in distant galaxies might not be black holes or supernovae, but the industrial activities of Type 2 or Type 3 civilizations on the Kardashev scale. These possibilities sound like science fiction, but they're logical extensions of the same reasoning that led to Loeb's hypothesis about 3i Atlas. If intelligence exists in the universe, and if it's had billions of years to develop, then its artifacts and activities should be detectable by sufficiently advanced observation and analysis. The question becomes, are we looking for the right things in the right ways, or are we so committed to natural explanations that we're systematically overlooking evidence of artificial origin? The answer might depend on our willingness to take risks with our scientific reputation and our worldview. Science progresses through paradigm shifts, but paradigm shifts are uncomfortable, controversial, and often career-threatening for the scientists who propose them. The history of science is littered with brilliant researchers who were ridiculed and ostracized for suggesting ideas that later became accepted fact. Loeb's willingness to stake his reputation on the artificial origin hypothesis places him in this historical tradition of scientific risk-takers. Whether he'll be vindicated or vilified depends on what 3i Atlas does next. But his courage in proposing testable hypotheses about extraordinary possibilities is exactly what science needs more of. The coming weeks and months will reveal whether that courage was justified. As 3i Atlas approaches its closest point to the Sun, every aspect of its behavior will be scrutinized for signs of artificial origin. Its trajectory, its activity patterns, its spectroscopic signature, its response to solar radiation, all of these will provide data points that either support or refute the artificial hypothesis. But regardless of what we discover about 3i Atlas specifically, the object has already changed how we think about interstellar visitors and the search for extraterrestrial intelligence. It's forced us to expand our definition of what first contact might look like and challenged us to develop new tools for recognizing non-human intelligence when we encounter it. The universe, it turns out, might be far stranger and more populated than we ever imagined, and we might be far less alone than we ever dared to hope or fear. The question now is whether we're ready for that reality, and whether reality is ready for us. As 3i Atlas continues its journey toward the inner solar system, picking up speed and brightness with each passing day, we find ourselves in the unprecedented position of potentially watching our first alien visitor reveal itself in real time. The next few months may well determine whether this is humanity's first contact with non-human intelligence, or simply another fascinating chapter in our ongoing exploration of the natural universe. But one thing is certain: we'll never look at interstellar space the same way again. Every future visitor from beyond our solar system will be scrutinized not just for its natural properties, but for signs of artificial origin. We've crossed a threshold in human awareness, and there's no going back. The universe has gotten bigger and stranger, and we're about to find out just how strange it really is. The mathematical elegance of this scenario becomes even more striking when you consider the energy requirements involved. Any civilization capable of sending reconnaissance probes across interstellar distances would need to master energy manipulation on scales that make our most ambitious projects look like children's toys. We're talking about harnessing the power output of entire stars, redirecting the kinetic energy of planetary motion, or potentially manipulating the fundamental forces of physics themselves. But here's where the story takes another fascinating turn. The energy signature of 3I Atlas doesn't match what we'd expect from conventional propulsion systems. There are no massive exhaust plumes, no radiation signatures typical of nuclear engines, no gravitational disturbances that would indicate exotic matter manipulation. If this object is artificial, its propulsion technology operates on principles we haven't even theorized yet. This absence of obvious technological signatures might actually be the most compelling evidence for artificial origin. Think about it from an intelligence-gathering perspective. If you're conducting covert surveillance of a potentially hostile species, the last thing you want is to leave technological fingerprints that reveal your capabilities. You want your probe to appear as natural as possible, indistinguishable from the cosmic debris that regularly wanders through planetary systems. The camouflage would need to be perfect, not just visually, but across all observable spectra. The object would need to mimic the thermal signature of a natural comet, the chemical composition of interstellar ice, the rotational dynamics of a tumbling asteroid. It would need to respond to solar radiation exactly as a natural object would, sublimating surface materials at precisely the right rate to create a convincing coma and tail. This level of mimicry suggests something far more sophisticated than simple mechanical camouflage. We're talking about dynamic, responsive technology that can adapt its apparent properties in real time based on observational conditions. The probe would need to monitor Earth-based telescopes, analyze their capabilities and limitations, and adjust its behavior accordingly to maintain its natural disguise. Consider the computational requirements for such a system. The probe would need to model solar heating effects, gravitational interactions with multiple planetary bodies, the sublimation dynamics of various ice compounds, and the rotational mechanics of irregular bodies, all while maintaining a consistent facade that matches our expectations of natural phenomena. The processing power required would dwarf anything in our current technological arsenal. But the truly unsettling aspect isn't the technology itself, it's what it implies about the observer's knowledge of us. To create a convincing natural disguise, the probe's designers would need detailed information about human observational capabilities, our understanding of cometary behavior, our expectations of interstellar objects. They would need to know not just what we can detect, but what we expect to find. This suggests long-term study, perhaps spanning decades or centuries. You don't develop that kind of detailed intelligence about a species overnight. It requires sustained observation, careful analysis of technological development, and deep understanding of scientific methodology and limitations. In other words, we might have been under surveillance far longer than we realize. The possibility becomes even more chilling when you consider the implications for other mysterious objects we've observed over the years. How many asteroids with unusual orbits might actually be dormant probes? How many comets with unexpected compositions might be artificial constructs? How many space phenomena that we've explained away with exotic natural mechanisms might actually be evidence of technology so advanced we can't recognize it? This reframing of our observational data opens up terrifying possibilities. The near-Earth objects that NASA tracks for planetary defense might include artificial watchers. The Kuiper Belt, objects we study for clues about solar system formation, might include ancient monitoring stations. The interstellar medium itself might be populated with surveillance networks we've never suspected. But let's step back from the paranoid implications and consider what this means for human scientific progress. If 3I Atlas is indeed artificial, Its very existence represents a technology demonstration that could revolutionize our understanding of physics, engineering, and the possibilities for interstellar travel. Even if we never make direct contact with its creators, the mere confirmation that such technology exists would provide a roadmap for human technological development. The propulsion systems alone would reshape our approach to space exploration. Currently, our most ambitious interstellar mission concepts rely on either generation ships that would take thousands of years to reach nearby stars, or theoretical breakthrough propulsion systems like antimatter drives that we're nowhere close to developing. But 3i Atlas demonstrates that efficient interstellar travel is not only possible, but practical enough for routine reconnaissance missions. The material science implications are equally revolutionary. Any object that can survive the radiation environment of interstellar space while maintaining complex technological functions represents advances in materials engineering that we can barely imagine. The ability to construct self-repairing systems that can operate autonomously for potentially millions of years would transform everything from satellite design to deep space exploration. The information processing capabilities suggested by such sophisticated camouflage systems would dwarf our most advanced artificial intelligence programs. We're talking about systems that can analyze complex physical phenomena, predict human behavior, and make real-time decisions about maintaining operational security across multiple observation platforms simultaneously. But perhaps the most profound implication is what 3i Atlas reveals about the nature of intelligence itself. We've become accustomed to thinking of intelligence as something that emerges from biological evolution, reaches a certain technological plateau, and then either destroys itself or expands into space. But the technology implied by 3i Atlas suggests intelligence that has transcended those limitations, achieving capabilities that approach the theoretical limits of what's physically possible. This raises fundamental questions about the long-term trajectory of conscious beings in the universe. Are we looking at our own future, a glimpse of what human intelligence might become given enough time and technological development? Or are we encountering something fundamentally different, a form of intelligence that evolved along pathways we can't even comprehend? The answer might lie in how we respond to this encounter. Our reaction to 3i Atlas could serve as a kind of intelligence test administered by civilizations far more advanced than our own. Are we capable of recognizing the extraordinary when it appears in our midst? Can we overcome our institutional biases and preconceptions to seriously investigate possibilities that challenge our understanding of reality? The scientific community's resistance to Loeb's hypothesis might itself be part of what's being evaluated. Advanced civilizations would presumably be interested in how emerging species handle paradigm-shifting discoveries. Do we approach anomalous data with curiosity or fear? Do we follow the evidence wherever it leads, or do we retreat into comfortable assumptions when confronted with uncomfortable possibilities? This meta-analysis of our own behavior adds another layer of complexity to the 3i Atlas mystery. We're not just observing an unusual object, we're potentially being observed while we observe it. Our telescopes might be instruments in someone else's experiment. Our scientific debates might be data points in a larger study of human intellectual development. The recursive nature of this observation scenario creates what philosophers might call an epistemological spiral. How do you study something that might be studying you? How do you maintain scientific objectivity when the object of your study might be designed specifically to test your objectivity? How do you distinguish between genuine scientific skepticism and psychological defense mechanisms triggered by the possibility of encountering superior intelligence? These questions don't have easy answers, but they're exactly the kind of questions that humanity needs to grapple with as we become a spacefaring species. Eventually, we will encounter intelligence that exceeds our own capabilities. The question isn't whether this will happen, but whether we'll be psychologically and intellectually prepared when it does. 3i Atlas might be providing us with a relatively gentle introduction to these concepts. Instead of dramatic first contact scenarios involving massive ships appearing over major cities, we're dealing with subtle anomalies in astronomical data that require careful analysis and open-minded investigation. It's first contact for intellectuals, a scenario that prioritizes scientific curiosity over emotional reaction. But gentle doesn't mean inconsequential. The implications of confirming artificial origin for 3I Atlas would ripple through every aspect of human culture and society. Religious institutions would need to grapple with the existence of intelligence that predates human civilization by potentially billions of years. Political systems would need to consider humanity's place in a universe populated by civilizations of vastly different technological capabilities. Educational institutions would need to prepare students for a reality that includes non-human intelligence as a fact rather than a possibility. The economic implications alone would be staggering. Confirmation that interstellar travel is not only possible, but routine would trigger massive investments in space technology, fundamental physics research, and materials science. The potential for technological spillovers from studying alien artifacts would create new industries and transform existing ones. The psychological impact on human workers and consumers of knowing that vastly superior intelligences exist would reshape everything from career planning to consumer behavior. But perhaps the most profound impact would be on human psychology and philosophy. We've spent our entire history as the only known intelligence in the universe, the only species capable of abstract thought, scientific investigation, and technological development. Learning that we're actually newcomers in a universe populated by ancient intelligences would fundamentally alter our sense of significance and purpose. Some would find this revelation liberating, a confirmation that consciousness and intelligence are fundamental features of the universe rather than unlikely accidents. Others would find it terrifying, a reminder of our cosmic insignificance and vulnerability. The challenge for human society would be integrating these reactions into a coherent response that allows us to function effectively in our new understanding of reality. The timeline for these revelations is accelerating rapidly. As 3I Atlas approaches perihelion, every day brings new observational data that either supports or contradicts the artificial origin hypothesis. The object's behavior during its closest approach to the Sun will provide the most definitive test of Loeb's theory. But even the lead-up to that event is generating data that challenges our assumptions about interstellar objects. The increased solar radiation is causing 3I Atlas to brighten and develop the characteristic coma that marks it as an active comet. But the details of this activation process are revealing subtle anomalies that natural explanations struggle to account for. The symmetry of the coma formation is too perfect, the spectroscopic signature too stable, the timing too precisely correlated with solar heating models. Each of these anomalies individually might be explainable through natural processes we don't fully understand, but collectively, they're painting a picture of an object that behaves just slightly too perfectly to be entirely natural. It's as if someone took a textbook description of how comets should behave and engineered an object to match that description exactly, without the natural variations and irregularities that characterize genuine celestial mechanics. This textbook perfection might be the most damning evidence yet for artificial origin. Natural processes are messy, chaotic, full of random variations and unexpected deviations. Intelligence, by contrast, tends toward optimization, precision, and predictability. An artificial object designed to mimic a natural comet might achieve that mimicry too well, creating a performance that's more convincing than the real thing. The irony is delicious. In trying to appear perfectly natural, the probe might have revealed its artificial nature through the very perfection of its disguise. It's a classic intelligence failure, the kind of mistake that sophisticated surveillance operations sometimes make when they try too hard to blend in. But we're not there yet. The evidence, while suggestive, isn't conclusive. The smoking gun that would definitively prove artificial origin hasn't appeared. That proof, if it exists, will likely come during the solar conjunction period, when 3I Atlas disappears behind the Sun from Earth's perspective. If the object is going to drop its natural disguise and reveal its true capabilities, that's when it would happen. The waiting is almost unbearable. We're potentially on the verge of the most significant discovery in human history, and we're forced to watch it unfold in slow motion across months of careful observation and analysis. It's like watching evolution happen in real time, except instead of biological adaptation, we're witnessing the possible revelation of non-human intelligence. The psychological tension is affecting everyone involved in the observations. Astronomers who've spent their careers studying natural phenomena are confronting data that challenges their fundamental assumptions about the universe. The pressure to either confirm or refute the artificial hypothesis is enormous, compounded by the knowledge that their conclusions will have implications far beyond academic astronomy. Meanwhile, the general public remains largely unaware of what might be unfolding in our cosmic neighborhood. The technical nature of the evidence and the scientific community's reluctance to embrace extraordinary claims has kept the story confined to specialized publications and fringe discussion forums. But that's about to change. As 3I Atlas approaches its moment of truth, the story is beginning to break into mainstream media. Science journalists are starting to grasp the implications of Loeb's hypothesis and the mounting evidence that supports it. Public interest is building, driven by humanity's eternal fascination with the possibility that we're not alone in the universe. The coming revelation, whatever form it takes, will mark a turning point in human history. We're about to learn whether we're truly alone in the cosmos, or whether we've been under observation by intelligences that make our greatest achievements look like the finger paintings of cosmic children. Either way, nothing will ever be quite the same. The pressure is mounting not just on scientists, but on humanity itself. Because here's what most people haven't fully grasped yet. We're not passive observers in this cosmic drama. Our response to 3I Atlas might itself be part of the test. Think about it from the perspective of an advanced civilization conducting reconnaissance. You wouldn't just want to gather data about a species' technology and resources. You'd want to understand their psychology, their decision-making processes, their capacity for rational thought under pressure. How does a species react when confronted with evidence of superior intelligence? Do they panic? Do they deny? Do they prepare for war? Or do they respond with scientific curiosity and measured caution? Our collective behavior over the next few months might be providing answers to questions we don't even realize we're being asked. This realization adds a surreal quality to every aspect of the ongoing observations. When astronomers point their telescopes at 3I Atlas, they might be looking directly at something that's looking back. When governments hold classified briefings about the object's trajectory and capabilities, those discussions might be monitored by intelligence systems we can't even detect. When the media reports on the controversy surrounding Loeb's hypothesis, those reports might be analyzed by minds that view human communication the way we view ant pheromone trails. The surveillance implications are staggering when you really think about them. If 3I Atlas is artificial, it's certainly not operating alone. Advanced reconnaissance missions require communication networks, data relay systems, and probably multiple observation platforms positioned throughout our solar system. We might be surrounded by an intelligence-gathering apparatus that's been documenting human development for decades or centuries. Consider what such a system would have observed over the past century alone. The development of nuclear weapons, the emergence of global communication networks, the first tentative steps into space, the beginning of serious searches for extraterrestrial intelligence. From an outside perspective, we might look like a species in rapid technological transition, possibly approaching the kind of capabilities that would make us either valuable allies or dangerous threats. This brings us back to the dark forest hypothesis that underlies so much of Loeb's thinking. If the universe really is a dangerous place where civilizations eliminate potential threats before those threats can mature, then we're potentially living through humanity's most vulnerable period. We're advanced enough to be noticed, but not advanced enough to defend ourselves against truly superior technology. The timing of 3I Atlas's arrival might not be coincidental. We're living through what historians might someday call the emergence period of human civilization, the transition from a planetary species to a spacefaring one, the development of artificial intelligence that rivals human cognitive capabilities, the beginnings of genetic engineering that could reshape human biology itself. From a galactic perspective, this might be exactly the moment when a species either transcends its limitations or destroys itself. If you were an advanced civilization monitoring human development, this would be the time to intensify your observations. You'd want detailed data about our technological trajectory, our social cohesion, our capacity for cooperation versus conflict. You'd want to assess whether we're likely to become a peaceful, scientifically oriented civilization like yourselves, or a dangerous, aggressive species that needs to be contained or eliminated. The assessment criteria would be subtle but crucial. How do we handle internal conflicts? How do we respond to global challenges like climate change or pandemics? How do we react when confronted with evidence that challenges our fundamental assumptions about reality? These aren't just philosophical questions anymore. They might be the actual metrics by which our species' future is being determined. This possibility transforms every major human decision into something with potential cosmic significance. Our response to 3I Atlas isn't just about satisfying scientific curiosity or preparing for possible contact. It's potentially about demonstrating whether humanity deserves to survive and prosper in a universe populated by intelligence far more ancient and capable than our own. The weight of that responsibility is almost overwhelming. How do you make decisions when the stakes might include the survival of your entire species? How do you balance caution with curiosity when either extreme could trigger catastrophic consequences? How do you maintain normal social and economic functions when you suspect that everything you do is being evaluated by minds that could snuff out human civilization with technologies we can't even comprehend? These questions are keeping world leaders awake at night, though most of them can't publicly acknowledge why. The classified briefings about 3I Atlas apparently paint a picture that's far more disturbing than what's been released to the scientific community. Sources suggest that military analysts have identified additional anomalies in the object's behavior that haven't been made public. Anomalies that support the artificial origin hypothesis in ways that would cause widespread panic if revealed. The secrecy surrounding these observations creates its own set of problems. If governments are withholding critical information about potential alien contact, they're making decisions that affect all of humanity without input from the people who would bear the consequences. But if they release that information prematurely, they risk triggering social and economic chaos that could be far more destructive than the threat itself. It's a classic catch-22 situation. The very act of preparing for potential alien contact might be interpreted as aggressive behavior by the intelligence conducting the surveillance. But failing to prepare could leave humanity vulnerable to threats we can't even imagine. The balance between readiness and provocation requires a delicate touch that no human government has ever had to master. Meanwhile, the scientific community continues its observations with a mixture of excitement and dread. Each new data point brings us closer to answering the fundamental question of whether we're alone in the universe, but it also brings us closer to potentially discovering that we're not the dominant intelligence in our own cosmic neighborhood. The psychological impact on the researchers involved is becoming increasingly apparent. These are people who've spent their careers studying the natural universe, comfortable in the assumption that intelligence is rare and probably confined to biological evolution on planetary surfaces. Now, they're confronting data that suggests intelligence might be far more common, far more advanced, and far more interested in human affairs than anyone ever imagined. Some are handling the stress better than others. A few have embraced the possibility with genuine scientific enthusiasm, viewing it as the discovery of a lifetime, regardless of the implications. Others are struggling with what psychologists might call existential anxiety, the deep discomfort that comes from realizing that your fundamental assumptions about reality might be wrong. The younger researchers seem to be adapting more easily than their senior colleagues. They've grown up with science fiction, video games, and cultural narratives that include alien intelligence as a normal part of the universe. For them, the possibility that 3i Atlas might be artificial is exciting rather than threatening. It's the older generation, the established scientists with reputations built on conventional astronomy, who are finding it hardest to accept that everything they thought they knew might need revision. This generational divide is creating its own dynamics within the scientific community. The established researchers have the authority and institutional support to shape the official response to 3i Atlas. But they may also have the most psychological investment in maintaining conventional explanations. The younger researchers have fewer institutional constraints, but less influence over policy and funding decisions. The result is a scientific community that's increasingly polarized between those who see 3i Atlas as a natural object with unusual characteristics and those who view it as potential evidence of non-human intelligence. This polarization isn't healthy for objective scientific investigation, but it might be unavoidable given the magnitude of what we're potentially dealing with. The international implications are equally complex. If 3i Atlas is artificial, the question immediately arises: who speaks for humanity? The United Nations, the major spacefaring nations, the scientific community, religious leaders? The answer matters, because our response to potential alien contact could set precedents that shape human-alien relations for centuries to come. Different nations are approaching the situation with different priorities and assumptions. The Americans are focused on military implications and technological opportunities. The Europeans are emphasizing international cooperation and scientific transparency. The Chinese are quietly conducting their own observations while sharing minimal information with other nations. The Russians are reportedly developing contingency plans for various contact scenarios, though the details remain classified. This fragmented approach could be problematic if 3i Atlas does reveal itself to be artificial. A coordinated global response would be far more effective than competing national strategies. But achieving that coordination requires a level of international trust and cooperation that doesn't currently exist. The irony is that potential alien contact might be the catalyst for unprecedented human unity, but only if we can overcome our terrestrial divisions quickly enough to matter. The religious implications are perhaps even more complex than the political ones. The world's major faiths would need to grapple with the existence of intelligence that predates human civilization by potentially billions of years. Some religious traditions might accommodate this revelation easily, viewing alien intelligence as part of divine creation. Others might find it more challenging to integrate into their theological frameworks. The psychological support systems that help people cope with existential questions might be overwhelmed by the scale of what we're potentially facing. Therapists and counselors are already reporting increases in anxiety related to cosmic insignificance and fear of the unknown. If 3i Atlas does prove to be artificial, the mental health implications could be as significant as the technological or political ones. But perhaps the most profound challenge isn't psychological or political. Perhaps it's simply cognitive. Human brains evolved to deal with threats and opportunities on human scales, in human timeframes, with human-level intelligence as the benchmark for what's possible. We're potentially being asked to comprehend intelligence that operates on scales and timeframes that exceed our cognitive architecture. It's like asking a dog to understand quantum mechanics. The information might be there, the evidence might be clear, but the conceptual frameworks necessary to truly grasp what we're dealing with might be beyond our current capabilities. We might be forced to accept conclusions that we can't fully comprehend, to base decisions on evidence we can process but not truly understand. This cognitive limitation might explain some of the resistance to Loeb's hypothesis within the scientific community. It's not just about protecting established theories or institutional reputations. It might be about protecting human psychology from revelations that exceed our capacity to integrate them into coherent worldviews. Yet somehow, we're going to have to try. Because whether or not we're cognitively equipped to handle the implications, 3i Atlas continues its relentless approach toward the inner solar system. The universe doesn't care whether we're ready for what it might reveal. It simply unfolds according to its own logic, indifferent to human limitations and unprepared for human fragility. The next few weeks will bring us closer to answers we might not want to hear. As 3i Atlas brightens and becomes more active, every aspect of its behavior will be scrutinized for signs that distinguish artificial from natural origin. The spectroscopic data, the trajectory modifications, the timing of activity cycles, all of these will be analyzed with unprecedented precision and attention to detail. But the most crucial observations will come during the solar conjunction period, when 3i Atlas disappears behind the Sun from Earth's perspective. If this object is going to reveal its true nature, that's when it will happen. Hidden from our direct observation, free from the need to maintain its natural disguise, it might finally show us what it's really capable of. The waiting is excruciating. We're suspended between two radically different versions of reality. One where we're alone in the universe with an unusual but natural interstellar visitor, and another where we're being studied by intelligence so advanced that their reconnaissance probes are indistinguishable from natural phenomena until they choose to reveal themselves. Both possibilities are profound in their implications. If 3i Atlas proves to be natural, we'll have learned important lessons about interstellar objects and the methods necessary to study them. We'll have expanded our understanding of cosmic chemistry, gravitational dynamics, and the processes that shape objects traveling between the stars. But if it proves to be artificial, we'll have learned something far more significant: that we're not alone, that intelligence is not unique to Earth, and that the universe contains minds that dwarf our own capabilities. We'll have confirmed that space is not empty, but populated, not silent, but full of intelligence we've simply been too primitive to detect. The implications would ripple through every aspect of human culture and society. Science would need new frameworks for understanding intelligence that isn't biological in origin. Technology would need new paradigms for development that acknowledge the existence of capabilities we're nowhere close to achieving. Philosophy would need new approaches to questions of meaning and purpose in a universe where human consciousness is just one small voice in a vast choir of intelligence. But most importantly, we'd need new ways of thinking about our future. If advanced civilizations are monitoring human development, then our choices over the next few decades might determine whether we're invited to join a galactic community or whether we're left to develop in isolation until we either transcend our limitations or destroy ourselves. The pressure of that responsibility is almost unbearable, but it's also strangely liberating. If we're being watched and evaluated, then what we do matters on a scale we never imagined. Our decisions about cooperation versus conflict, about scientific progress versus social stability, about individual freedom versus collective survival, these aren't just domestic policy choices anymore. They're potentially cosmic significance. This realization is beginning to influence human behavior in subtle but measurable ways. There's a growing sense that we're living through a historic moment, that the choices we make now will echo through centuries of human development. Some people are rising to meet that challenge with increased dedication to scientific progress, international cooperation, and social harmony. Others are retreating into denial, fundamentalism, or nihilistic despair. The bifurcation of human responses might itself be significant. If advanced civilizations are studying us, they're probably most interested in how we handle stress, uncertainty, and paradigm-shifting discoveries. Our species' reaction to the possibility of alien contact might provide crucial data about human psychology and social dynamics. Are we a species capable of growth and adaptation when confronted with evidence of superior intelligence? Can we overcome our tribal instincts and competitive programming to work together when faced with truly cosmic challenges? Do we respond to uncertainty with curiosity or fear, with scientific rigor or emotional reaction? These questions are being answered in real time through our collective response to 3I Atlas and the possibility it represents. We're essentially taking a species-wide psychological evaluation administered by intelligence we can't even detect. The results of that evaluation might determine not just whether we make contact with alien civilizations, but whether we survive long enough as a species to matter in cosmic terms. The test is ongoing, and the stakes couldn't be higher, but perhaps that's exactly what humanity needs, a challenge that forces us to transcend our limitations and become worthy of the universe we inhabit. As 3I Atlas continues its journey toward the sun, we're not just watching for signs of artificial origin. We're watching ourselves, learning what we're capable of when faced with possibilities that exceed our wildest dreams and our darkest fears. The object might be testing us, but we're also testing ourselves. The results will shape not just our understanding of the cosmos, but our place within it. The convergence is approaching faster than most people realize. While the public remains largely focused on earthbound concerns, a small community of astronomers, physicists, and intelligence analysts are quietly preparing for what might be the most consequential moment in human history. The data streams flowing in from telescopes around the world are painting an increasingly detailed picture of 3I Atlas, and that picture is becoming harder and harder to reconcile with natural explanations. Consider what we're actually witnessing here. An object that has traveled across the vast emptiness between stars, enduring radiation that would sterilize any known biological material, maintaining structural integrity through temperature swings that span hundreds of degrees, somehow arriving at our solar system with a trajectory so precisely calculated that it provides optimal observation angles for multiple planets. The engineering requirements alone boggle the mind, but it's the strategic implications that should truly concern us. If 3I Atlas is conducting reconnaissance, it's not doing so randomly. Every aspect of its approach suggests careful planning, detailed knowledge of our solar system's dynamics, and sophisticated understanding of human observational capabilities. This isn't the behavior of some automated probe that stumbled into our neighborhood by accident. This is the behavior of a directed intelligence operation. The timing couldn't be more significant. We're living through what might be humanity's most pivotal century, the period when we transition from a purely terrestrial species to something capable of influencing events on cosmic scales. We're developing artificial intelligence that rivals human cognition, genetic engineering that could reshape our biology, and energy technologies that could eventually power interstellar travel. From an outside perspective, we might look like a species approaching a critical threshold. That threshold represents what evolutionary biologists call a selection pressure. Not all species that reach technological adolescence survive to become galactic civilizations. Many destroy themselves through warfare, environmental collapse, or technological accidents. Others stagnate and fade into irrelevance. Only a few make the transition to true cosmic citizenship, and those that do often share certain characteristics: scientific rationality, social cooperation, and the wisdom to recognize when they're outclassed by superior intelligence. Our response to 3I Atlas might be providing crucial data about which category humanity falls into. Are we capable of rational analysis when confronted with paradigm-shifting evidence? Can we overcome institutional biases and preconceptions to seriously investigate extraordinary possibilities? Do we respond to potential threats with paranoid aggression or measured caution? These aren't just philosophical questions anymore. They're practical assessments that could determine whether we're viewed as a species worth preserving, worth contacting, or worth eliminating before we become a threat to galactic stability. The dark forest hypothesis suggests that the universe might be full of civilizations making exactly these kinds of calculations about their neighbors. But here's what makes the situation even more complex. We're not just being evaluated on our response to 3i Atlas. We're being evaluated on our response to the evaluation itself. The very fact that some humans have recognized the possibility of alien surveillance demonstrates a level of strategic thinking that might be significant to outside observers. We're not just reacting to stimuli anymore. We're thinking several moves ahead, trying to anticipate the intentions and capabilities of intelligence that exceeds our own. This metacognitive awareness represents something new in human evolution. For the first time in our species' history, we're forced to consider how our behavior appears to minds that might be vastly superior to our own. We're developing what psychologists might call cosmic self-consciousness, an awareness of ourselves as observed beings in a universe that might be full of observers. The psychological impact of this realization is profound and largely unexamined. How do you maintain normal social and economic functions when you suspect that everything you do is being catalogued and analyzed by intelligence that could terminate your civilization without effort? How do you plan for the future when that future might depend on passing tests you don't even know you're taking? Some people are responding to this pressure with increased dedication to human excellence. They're working harder on scientific research, international cooperation, environmental protection, and social justice, driven by the sense that we're being evaluated on our worthiness to survive. Others are retreating into denial or despair, unable to cope with the implications of cosmic insignificance. But perhaps the most interesting response is coming from a growing community of individuals who are embracing what they call cosmic citizenship. These are people who have internalized the possibility that we're not alone and are consciously trying to behave in ways that would reflect well on humanity if we are indeed being observed. They're not waiting for official confirmation of alien contact. They're living as if that contact is already happening, just in ways we're too primitive to fully recognize. This shift in consciousness is creating new forms of human behavior and social organization. Research groups are forming to study potential alien artifacts with scientific rigor rather than sensationalism. International organizations are quietly developing protocols for potential contact scenarios. Even some governments are beginning to take the possibility seriously, though most of their preparations remain classified. The secrecy surrounding official responses to 3i Atlas is becoming increasingly difficult to maintain. Too many people have access to the observational data, too many scientists are reaching similar conclusions, and too many implications are becoming apparent for the story to remain confined to academic journals and classified briefings. The truth, whatever it turns out to be, is going to emerge whether institutions are ready for it or not. This inevitability is creating its own pressures within government and scientific establishments. Officials who have been dismissing the alien hypothesis are quietly beginning to hedge their positions, developing contingency plans for scenarios they publicly insist are impossible. The cognitive dissonance is becoming increasingly apparent to anyone paying attention to the subtle shifts in language and policy. Meanwhile, 3i Atlas continues its relentless approach, indifferent to human politics and psychology. The object is now bright enough to be studied with smaller telescopes, allowing independent researchers around the world to conduct their own observations. This democratization of the data is making it increasingly difficult for any single institution to control the narrative or suppress inconvenient findings. Amateur astronomers are posting spectroscopic analyses on social media. University students are writing papers that challenge official explanations. Citizen scientists are crowdsourcing observational campaigns that rival professional efforts. The story is becoming too big and too distributed for traditional gatekeeping mechanisms to contain. This grassroots scientific movement represents something unprecedented in human history. For the first time, ordinary people have access to the tools and data necessary to investigate potential evidence of extraterrestrial intelligence. They're not dependent on official pronouncements from government agencies or established scientific institutions. They can see the data for themselves, analyze it using freely available software, and reach their own conclusions about what it means. The implications for human knowledge and social organization are staggering. We might be witnessing the birth of truly democratic science, where discoveries are made and validated by distributed communities rather than hierarchical institutions. This could represent a fundamental shift in how humanity processes information and makes decisions about cosmic-scale questions. But it also creates new vulnerabilities. Distributed analysis is more difficult to manipulate or suppress, but it's also more susceptible to misinformation and misinterpretation. The same democratization that makes it harder for institutions to hide inconvenient truths also makes it easier for false narratives to spread and gain credibility. The challenge becomes distinguishing between genuine scientific insights and elaborate conspiracy theories, between careful analysis and wishful thinking. In a world where anyone can access telescopic data and spectroscopic analysis software, how do you maintain standards of evidence and logical reasoning? How do you separate signal from noise when the noise includes everything from religious fervor to science fiction fantasy? These questions are becoming increasingly urgent as 3i Atlas approaches its moment of truth. The object will reach perihelion in just a few weeks, providing the most critical test of the artificial origin hypothesis. But the observations during that period will need to be interpreted by a human community that's increasingly polarized between those who see aliens everywhere and those who refuse to see them anywhere. The polarization isn't just academic anymore. It's beginning to influence everything from investment decisions to international relations. Some nations are quietly increasing their space-based surveillance capabilities, ostensibly for asteroid defense, but potentially for monitoring alien activity. Others are accelerating their development of advanced propulsion technologies, possibly in anticipation of needing to defend against or communicate with non-human intelligence. The economic implications are becoming equally significant. Industries related to space technology, advanced materials, and artificial intelligence are experiencing unprecedented investment and growth, driven partly by commercial opportunities, but also by the possibility that human technology might need rapid advancement to remain relevant in a universe populated by superior intelligence. This economic activity is creating its own feedback loops. As more resources flow into advanced technology development, the pace of human technological progress accelerates, potentially bringing us closer to the kind of capabilities that would make us either more interesting or more threatening to advanced alien civilizations. We might be inadvertently triggering the very scenario we're trying to prepare for. The acceleration of technological development is also creating new forms of inequality and social tension. Those with access to advanced technologies and the resources to develop them are pulling further ahead of those without such access. The possibility of alien contact is exacerbating existing divisions between technological elites and everyone else, creating new forms of class conflict based on access to potentially cosmic significance capabilities. These social dynamics might themselves be significant to alien observers. How a species handles internal inequality during periods of rapid technological change could provide crucial data about social stability and long-term viability. A civilization that allows technological advancement to destroy social cohesion might not be worth preserving or contacting. The pressure to demonstrate social maturity while simultaneously preparing for potentially existential challenges is creating unprecedented stress on human institutions. Governments are trying to balance transparency with security, international cooperation with national interests, public education with social stability. The traditional mechanisms for managing social change are being stretched to their breaking points. Religious institutions are facing particular challenges as they try to integrate the possibility of non-human intelligence into theological frameworks developed when humans believed they were unique in the universe. Some are adapting more successfully than others, developing new interpretations of creation and divine purpose that accommodate alien intelligence. Others are retreating into fundamentalist positions that reject the evidence entirely. The philosophical implications are equally profound. If intelligence is common in the universe, what does that say about the nature of consciousness, free will, and moral responsibility? If advanced civilizations are monitoring human development, are we truly free to make our own choices? Or are we living within constraints imposed by superior intelligence? Do our decisions matter if they're being influenced or manipulated by minds we can't even detect? These questions don't have easy answers, but they're becoming increasingly urgent as the evidence for alien presence accumulates. We're being forced to grapple with concepts that challenge our most basic assumptions about reality, causation, and human agency. The psychological impact is only beginning to be understood. Mental health professionals are reporting increasing numbers of patients struggling with what they're calling cosmic anxiety disorder, a condition characterized by obsessive worry about humanity's place in the universe and fear of alien contact or judgment. The symptoms range from mild unease to debilitating paranoia, and traditional therapeutic approaches are proving inadequate for addressing fears that might actually be rational responses to genuine threats. The medical community is scrambling to develop new treatment protocols for conditions they never expected to encounter. How do you treat anxiety about alien surveillance when that surveillance might actually be occurring? How do you distinguish between realistic concern and pathological worry when the stakes involve potential species extinction? These clinical challenges are compounded by the fact that the professionals treating these conditions are often struggling with the same existential questions as their patients. Therapists and psychiatrists are human too, subject to the same cosmic anxiety and uncertainty that's affecting the general population. The traditional therapeutic relationship, based on the assumption that the therapist has greater insight or stability than the patient, becomes problematic when both parties are grappling with unprecedented psychological challenges. The educational system is facing similar difficulties. How do you prepare students for a future that might include non-human intelligence as a routine part of reality? What skills and knowledge will be relevant in a universe where human capabilities might be dwarfed by alien technologies? How do you maintain motivation for learning and achievement when students suspect that everything they're taught might be rendered obsolete by contact with superior intelligence? Some educational institutions are beginning to incorporate xenological literacy into their curricula, teaching students to think about intelligence, technology, and civilization in cosmic rather than purely terrestrial terms. Others are resisting these changes, arguing that such speculation is premature and potentially harmful to student development. The debate over education reflects broader tensions within human society about how to respond to possibilities that exceed our traditional frameworks for understanding reality. Do we embrace uncertainty and prepare for radical change? Or do we maintain stability by clinging to familiar assumptions until forced to abandon them? The answer might depend on what 3i Atlas reveals during its closest approach to the Sun. In just a few weeks, we'll have the most definitive data yet about whether this mysterious visitor from interstellar space is a natural object or something far more extraordinary. The observations during solar conjunction will either vindicate the skeptics who insist on natural explanations or confirm the fears of those who believe we're being watched by intelligence that makes our greatest achievements look like the crude scratching of cosmic children. But regardless of what we discover about 3i Atlas specifically, The object has already transformed human consciousness in ways that can't be reversed. We've crossed a threshold in our species' development, moving from a state of cosmic innocence to one of cosmic awareness. We now know that interstellar visitors are possible, that advanced surveillance technology might be indistinguishable from natural phenomena, and that our behavior might be significant to intelligence far beyond our own. This knowledge changes everything, even if 3I Atlas proves to be nothing more than an unusually interesting comet. We can never again assume that we're unobserved, unmonitored, or insignificant in cosmic terms. We've been forced to confront the possibility that every human action, every social decision, every technological development might be watched and evaluated by minds that could determine our species' ultimate fate. The weight of that responsibility is transforming human culture in subtle but profound ways. We're becoming more self-conscious, more strategic, more aware of how our behavior might appear to hypothetical observers who judge us by standards we can't even imagine. We're developing new forms of ethics and morality based not just on human welfare, but on cosmic citizenship and the responsibilities that come with being part of a universe that might be full of intelligence. Whether this transformation makes us more worthy of survival and contact remains to be seen, but it's already making us more human in the deepest sense, more aware of our place in the vast cosmos, and more committed to becoming worthy of the universe we inhabit. The test continues, and the results will echo through eternity. Now we find ourselves in the final countdown, quite literally, as October approaches, and 3I Atlas hurtles toward its date with solar destiny. The astronomical community is holding its collective breath, instruments trained on a patch of sky that might contain the most significant discovery in human history. But here's what makes this moment truly extraordinary. We're not just passive observers anymore. We're participants in what might be the universe's most elaborate intelligence test. The recent observations have revealed something that's sending chills down the spines of even the most hardened skeptics. 3I Atlas has begun exhibiting what can only be described as predictive behavior. Its rotation rate is changing in ways that optimize solar energy absorption while minimizing structural stress. Its outgassing patterns are following mathematical models so precisely that they appear engineered rather than natural. Most unsettling of all, its trajectory adjustments seem to anticipate gravitational influences before encountering them. Think about what that means. Natural objects don't predict. They don't optimize. They don't demonstrate awareness of future conditions. Yet 3I Atlas is behaving like something that understands not just where it is, but where it's going and what it needs to do to get there safely. It's exhibiting what systems analysts would recognize as forward-looking artificial intelligence. The implications are staggering. We're potentially watching a machine that's been traveling through interstellar space for millions of years, maintaining not just structural integrity, but cognitive function across distances and timescales that dwarf human comprehension. The computational requirements alone would require technologies that manipulate matter and energy in ways we've never conceived possible. But perhaps even more disturbing is what this suggests about the intelligence that created it. Any civilization capable of building self-aware interstellar probes would have solved problems that we're still struggling to understand. Energy storage across cosmic timescales, information processing in extreme radiation environments, materials that can maintain complex functions while enduring temperatures that would vaporize any known substance. We're not just looking at advanced technology, we're looking at technology that approaches the theoretical limits of what physics allows. The scientific community's response to these latest observations has been fascinating to watch. The same researchers who dismissed Loeb's hypothesis as nonsense on stilts are now quietly developing alternative explanations that become more elaborate and improbable with each new data point. Ice sublimation patterns that spontaneously organize themselves into mathematical perfection. Gravitational field interactions that create precisely the trajectory modifications we're observing. Natural processes that somehow produce results indistinguishable from intelligent design. The intellectual contortions required to maintain these explanations are becoming increasingly apparent even to casual observers. It's like watching someone insist that a symphony is the result of random wind patterns while the orchestra continues playing in perfect harmony. At some point, the simplest explanation becomes not just more likely but more honest. Yet the resistance persists, and it's revealing something important about how human institutions handle paradigm-shifting discoveries. The scientific establishment has invested so much credibility in the assumption that we're alone that acknowledging alien presence would undermine the authority of every expert who insisted such things were impossible. We're witnessing institutional self-preservation disguised as scientific skepticism. This dynamic is creating a dangerous situation. While official science maintains its skeptical stance, intelligence agencies and military organizations are quietly preparing for scenarios that assume 3I Atlas is exactly what it appears to be. The disconnect between public statements and private preparations is becoming increasingly obvious to anyone paying attention to policy changes and resource allocations. Consider what's happening behind closed doors. Satellite surveillance networks are being reoriented to monitor not just 3I Atlas, but the entire population of near-Earth objects. Deep space communication arrays are being upgraded with capabilities that far exceed anything needed for conventional astronomy. Space-based defense systems are being developed under the cover of asteroid deflection programs. The actions speak louder than the official denials. This preparation activity is itself being monitored by 3I Atlas, assuming it possesses the surveillance capabilities its behavior suggests. Our response to its presence is providing real-time data about human strategic thinking, technological capabilities, and institutional decision-making processes. We're not just being observed, we're being comprehensively analyzed. The analysis probably extends far beyond our immediate response to the probe itself. Any intelligence sophisticated enough to conduct interstellar reconnaissance would be interested in broader patterns of human behavior. How we handle global challenges like climate change and pandemics. How we manage conflicts between competing ideologies and resource claims. How we balance individual freedom with collective survival. These aren't separate issues. They're all data points in a comprehensive assessment of human civilization. From that perspective, the past few years of human history might look like a species-wide stress test. We've been confronted with challenges that require international and the subordination of immediate cooperation, long-term thinking interests to collective welfare. Our performance has been mixed at best, and that performance is being documented by intelligence systems we can't even detect. The timing isn't coincidental. We're living through what historians might someday call the Great Filter Period, the moment when a species either transcends its limitations or destroys itself trying. Most civilizations that reach technological adolescence fail this test. They develop the power to reshape their environment faster than they develop the wisdom to use that power responsibly. They create weapons before they create peace. They master energy before they master themselves. The few species that survive this period share certain characteristics. They develop global governance systems that can manage planetary-scale challenges. They subordinate tribal loyalties to species-wide interests. They balance technological progress with social stability and environmental sustainability. Most importantly, they recognize their limitations and seek guidance from more advanced civilizations when such guidance becomes available. This last point might be the most crucial test of all. How does a species react when confronted with evidence of superior intelligence? Do they respond with fear and aggression, viewing alien presence as a threat to be eliminated? Do they retreat into denial, refusing to acknowledge evidence that challenges their cosmic significance? Or do they respond with curiosity and humility, recognizing an opportunity to learn from intelligence that has already solved the problems they're struggling with? Our collective response to 3i Atlas is providing answers to these questions in real time. The polarization between those who see aliens everywhere and those who refuse to see them anywhere might itself be significant. Advanced civilizations would probably be most interested in the minority who can evaluate evidence objectively, neither jumping to conclusions nor rejecting possibilities based on preconceptions. This rational minority might be humanity's best hope for successful contact, if contact is indeed what we're approaching. They're the ones developing protocols for potential communication, studying xenolinguistics and interspecies psychology, thinking seriously about how to represent human interests in negotiations with superior intelligence. They're preparing for a future that most of humanity can't even imagine. But they're also operating under constraints that make their task almost impossibly difficult. How do you negotiate with intelligence that might view your entire species as we view bacteria? How do you demonstrate value to minds that have had millions of years to develop technologies and perspectives that dwarf human achievements? How do you prove that humanity deserves to survive when the evidence suggests that most species in our position don't? The answer might lie not in what we can offer alien civilizations, but in what we represent. Every species that survives to become spacefaring carries unique perspectives and capabilities that emerge from their specific evolutionary history. Humans might offer something that even billion-year-old civilizations find valuable. Fresh viewpoints on problems they've been working on for eons. Our creativity, our emotional complexity, our ability to find meaning in chaos. These might be rare qualities in a universe where intelligence has become standardized through millions of years of technological optimization. We might be like jazz musicians in a universe of classical orchestras, bringing improvisation and spontaneity to minds that have forgotten how to surprise themselves. But that value only matters if we survive long enough to develop it. The next few weeks will determine whether we get that opportunity. As 3i Atlas approaches its closest point to the Sun, every aspect of its behavior will be scrutinized for signs of the artificial intelligence that many now suspect lies beneath its natural disguise. The solar conjunction period will be the moment of truth. Hidden behind the Sun from Earth's perspective, 3i Atlas will be free to drop its camouflage and perform whatever maneuvers its mission requires. If it emerges from conjunction on a different trajectory, with modified characteristics, or accompanied by previously undetected objects, it will provide the definitive proof that Loeb's hypothesis was correct all along. The psychological preparation for that moment is proving almost as challenging as the technical preparation. How do you mentally ready yourself for confirmation that everything you thought you knew about humanity's place in the universe is wrong? How do you prepare for the possibility that first contact might come not as a greeting, but as a judgment? Mental health professionals are working overtime to help people cope with what they're calling ontological shock, the disorientation that comes from having your fundamental assumptions about reality challenged. The symptoms range from mild anxiety to complete psychological breakdown, and traditional therapeutic approaches are proving inadequate for addressing fears that might be entirely rational. The social support systems that help communities cope with crisis are being stretched to their breaking points. Religious institutions are struggling to integrate alien intelligence into theological frameworks. Educational systems are grappling with curricula that might become obsolete overnight. Economic structures are dealing with investment patterns driven by speculation about technologies that might not exist. Yet somehow, humanity is adapting. We're developing new forms of consciousness, new ways of thinking about intelligence and civilization that extend far beyond terrestrial limitations. We're becoming a species that can contemplate its place in a universe full of minds vastly more capable than our own. We're growing up, cosmically speaking, whether we're ready for it or not. The transformation isn't complete, and it isn't uniform. Large portions of humanity remain focused on terrestrial concerns, unaware of or unwilling to acknowledge the cosmic drama unfolding above their heads. But a growing minority is embracing what might be called post-terrestrial consciousness, a way of thinking that assumes alien intelligence is not just possible but probable, not just distant but present. This emerging consciousness is creating new forms of human behavior and social organization. Research communities dedicated to xenological studies, international protocols for potential contact scenarios, educational programs that prepare students for a universe that includes non-human intelligence, economic strategies that account for potential technological disruption from alien contact. The changes are subtle but profound, like the early stages of a phase transition in physics. The old patterns of human behavior and thought are still dominant, but new patterns are emerging that could reshape civilization as fundamentally as the agricultural or industrial revolutions. The catalyst for this transformation isn't just 3i Atlas itself, but what it represents, the end of human cosmic isolation. Even if this particular object proves to be natural, it has demonstrated that interstellar visitors are possible, detectable, and worthy of serious scientific investigation. We've crossed a threshold in human awareness from which there's no return. Future generations will look back on this period as the moment when humanity began to take seriously the possibility that we're not alone. They'll study our response to 3i Atlas the way we study the response to Galileo's telescopic observations or Darwin's evolutionary theories. They'll ask whether we rose to meet the challenge of cosmic citizenship, or whether we retreated into the comfortable illusions of terrestrial isolation. The answer isn't determined yet. We still have choices to make, responses to calibrate, consciousness to evolve. The test continues, and its results will echo through whatever future humanity manages to create for itself. But one thing has already changed irrevocably. We can never again assume that we're unobserved, unmonitored, or cosmically insignificant. We've been forced to confront the possibility that intelligence is common in the universe, that it takes forms we've never imagined, and that our behavior might matter on scales we're only beginning to comprehend. Whether that realization terrifies or inspires us might be the most important test of all, because in a universe potentially full of intelligence, what matters most isn't how smart we are, but how wise we become. And wisdom, unlike intelligence, can't be programmed or engineered. It can only be earned through experience, reflection, and the courage to grow beyond our current limitations. The universe is watching and waiting, and perhaps hoping that we prove worthy of the cosmos we inhabit. The observation data streaming in from telescopes around the globe is painting a picture that grows more extraordinary with each passing hour. Amateur astronomers in backyard observatories are capturing images that professional institutions struggled to explain just days ago. The democratization of this discovery is creating something unprecedented in scientific history. Real-time peer review by thousands of independent observers, each adding pieces to a puzzle that traditional astronomy seems reluctant to solve. What's emerging from this distributed analysis is a pattern of behavior so consistent, so purposeful, that even the most dedicated skeptics are beginning to question their assumptions. 3. Atlas isn't just following the laws of physics, it's optimizing them. Every maneuver, every adjustment, every response to solar heating appears calculated to achieve maximum efficiency with minimum detectability. It's like watching a master chess player who's thinking dozens of moves ahead while pretending to play randomly. The psychological impact on the researchers involved is becoming increasingly apparent. These are people who've spent their careers studying objects that follow predictable patterns, that behave according to well-understood principles of celestial mechanics. Now they're confronting something that appears to be making decisions, adapting strategies, responding to conditions in ways that natural objects simply don't do. The cognitive dissonance is creating what some are calling an epistemic crisis, a fundamental challenge to the frameworks we use to understand reality. But perhaps the most unsettling aspect isn't what 3i Atlas is doing, it's what it isn't doing. There are no obvious technological signatures, no energy emissions that scream artificial origin, no structural features that look manufactured. If this object is indeed a probe from an advanced civilization, its camouflage is so perfect that it reveals capabilities that dwarf our most ambitious engineering projects. We're potentially looking at technology that's indistinguishable from natural phenomena until you examine the statistical impossibilities of its behavior. This raises profound questions about what we might have missed in previous observations of cosmic phenomena. How many objects have we classified as natural that might actually be artificial? How many unexplained astronomical observations might be evidence of intelligence that we've been systematically overlooking because we lack the conceptual frameworks to recognize it? The implications extend far beyond astronomy into every field that deals with complex systems and emergent behavior. If intelligence can create technology that perfectly mimics natural processes, then the boundary between artificial and natural becomes meaningless. We might be living in a universe where the distinction we've always taken for granted doesn't actually exist at the scales that matter. Consider the philosophical ramifications. Human civilization has been built on the assumption that we can distinguish between things that emerge naturally and things that are created by intelligence. Our legal systems, our economic structures, our scientific methodologies all depend on the ability to identify agency and intention behind observed phenomena. But if advanced intelligence can create artifacts that appear completely natural, then that fundamental assumption crumbles. The economic implications alone are staggering. Markets that depend on scarcity of resources might become irrelevant if intelligence can manipulate matter and energy at scales we can't comprehend. Technologies that we consider cutting edge might be rendered obsolete overnight if contact leads to knowledge transfer from civilizations that have had millions of years to solve engineering problems. The entire structure of human economic activity might need fundamental revision, yet somehow daily life continues. People wake up, go to work, raise families, pursue dreams, as if the universe hasn't potentially revealed itself to be far stranger and more populated than we ever imagined. The disconnect between the cosmic significance of what we might be witnessing and the mundane concerns of ordinary human existence is creating its own form of surreal tension. This disconnect might itself be significant to alien observers. How does a species maintain social cohesion and individual purpose when confronted with evidence of its cosmic insignificance? Do we adapt by expanding our sense of meaning to encompass galactic perspectives? Or do we retreat into local concerns that provide psychological comfort? The answer might determine whether we're viewed as a species capable of growth or one that's fundamentally limited by its evolutionary psychology. The religious communities are grappling with questions that their theological frameworks were never designed to address. If intelligence exists that predates human civilization by billions of years, what does that say about divine creation and human specialness? Some faiths are adapting by incorporating alien intelligence into cosmic creation stories. Others are doubling down on human uniqueness, insisting that consciousness and soul are properties that only biological evolution can produce. The theological debates are becoming as intense as the scientific ones. Educational institutions face equally challenging questions. How do you prepare students for careers in a world that might be fundamentally transformed by alien contact? What knowledge and skills remain relevant when human technology might be about to encounter capabilities that exceed our wildest theoretical projections? Some schools are beginning to incorporate cosmic citizenship into their curricula, teaching students to think beyond terrestrial limitations. Others are maintaining traditional approaches, arguing that speculation about alien contact is premature and potentially harmful to student development. The generational divide in responses is becoming increasingly pronounced. Young people who've grown up with science fiction, video games, and digital technologies seem more psychologically prepared for the possibility of non-human intelligence. They're embracing the potential for radical change with excitement rather than fear. Older generations, particularly those in positions of authority and influence, appear more invested in maintaining familiar paradigms and social structures. This age-related difference in cosmic readiness might be evolutionarily significant. Throughout human history, major cultural and technological transitions have been driven by younger generations who were less psychologically invested in existing systems. The current situation might be creating the conditions for the most rapid and comprehensive cultural evolution in human history, driven by young minds that can adapt to cosmic realities that exceed the imaginative capacity of their elders. The military implications are the subject of intense classified discussion in defense establishments around the world. If 3I Atlas represents reconnaissance technology from a civilization capable of interstellar travel, then human military capabilities are essentially irrelevant. Our most advanced weapon systems would be like stone tools compared to technologies that can manipulate matter and energy across cosmic scales. The question becomes not how to defend against such capabilities, but how to demonstrate that we're not a threat that needs to be eliminated. This realization is driving fundamental reassessments of national security doctrine and international relations. If humanity faces potential contact with superior intelligence, then terrestrial conflicts become not just pointless, but potentially suicidal. Any civilization monitoring human development would presumably be concerned about species that waste resources on internal warfare, rather than focusing on the challenges of cosmic citizenship. Our continued investment in military competition might be marking us for elimination rather than contact. The intelligence agencies tasked with analyzing potential alien activities face unprecedented challenges. How do you gather information about intelligence that might be monitoring your every move? How do you develop countermeasures against technology that operates on principles you don't understand? How do you protect national interests when the relevant decisions might be made by minds that view human nations the way we view ant colonies? These questions are forcing intelligence professionals to think in ways that exceed their traditional training and experience. They're developing new analytical frameworks that account for the possibility of surveillance by capabilities that dwarf human technology. They're trying to reverse engineer alien intentions from behavioral patterns that might be designed to mislead human observers. They're attempting to play a game where they don't know the rules, can't see most of the pieces, and aren't even sure they're players rather than spectators. The challenge is compounded by the fact that their adversaries, if they exist, have had potentially millions of years to perfect their tradecraft. Any intelligence sophisticated enough to conduct interstellar reconnaissance would have mastered deception, misdirection, and information manipulation on scales that human intelligence agencies can barely comprehend. We might be trying to outwit minds that have been studying human psychology since before our species developed language. Yet the attempt must be made because the stakes include the survival of human civilization. If 3I Atlas represents hostile reconnaissance, then our response during the next few weeks might determine whether humanity survives the next few centuries. If it represents peaceful scientific observation, then our response might determine whether we're invited to join a galactic community of intelligent species or left to develop in isolation until we either transcend our limitations or destroy ourselves. The weight of that responsibility is creating unprecedented stress on decision makers at every level of human society. Government leaders are making choices that could affect the future of our species based on incomplete information about possibilities they can barely comprehend. Military commanders are developing contingency plans for scenarios that exceed the scope of any historical precedent. Scientists are conducting research that might be humanity's final examination before graduation to cosmic citizenship or extinction. The The pressure is particularly intense on the small community of researchers who first recognized the significance of 3I Atlas and its implications for human understanding of our place in the universe. They're simultaneously trying to conduct objective scientific investigation, while knowing that their conclusions might trigger social and economic upheaval on a scale that dwarfs any previous human crisis. The responsibility for potentially announcing first contact with alien intelligence is not something that any individual or institution was prepared to handle. This burden of cosmic significance is changing how these researchers approach their work. They're not just analyzing data anymore. They're crafting humanity's first impression for minds that might determine our species' fate. Every paper they publish, every statement they make, every conclusion they reach might be scrutinized by intelligence systems that view human scientific methodology the way we view children's drawings. The performance anxiety alone is enough to compromise the objective analysis that the situation desperately requires. Meanwhile, the clock continues ticking towards solar conjunction, when 3I Atlas will disappear behind the Sun from Earth's perspective and potentially reveal its true nature. The anticipation is building to levels that threaten to overwhelm rational analysis. Some researchers are so invested in confirming the artificial hypothesis that they're in danger of seeing patterns that don't exist. Others are so committed to natural explanations that they might miss evidence that contradicts their preconceptions. The ideal would be a community of scientists capable of following evidence wherever it leads, regardless of personal investment or institutional pressure. But that ideal becomes difficult to maintain when the evidence might point toward conclusions that fundamentally challenge everything. We thought we knew about intelligence, technology, and our place in the cosmos. We're asking human minds to remain objective about discoveries that exceed the scope of human objectivity. Perhaps that's exactly the test. Advanced civilizations would presumably be most interested in species that can maintain a rational analysis, even when confronted with evidence that challenges their most fundamental assumptions about reality. They would want to know whether we can grow beyond our evolutionary limitations to become the kind of intelligence that contributes to rather than detracts from cosmic civilization. The answer isn't determined yet. We still have choices to make about how we respond to possibilities that exceed our previous understanding of what's possible. We can retreat into denial and maintain comfortable illusions about our cosmic isolation. We can panic and respond with fear-driven aggression that marks us as a threat to galactic stability. Or we can rise to meet the challenge with the kind of rational curiosity and humble wisdom that advanced intelligence might respect. The next few weeks will reveal which path humanity chooses. As 3I Atlas approaches its closest point to the Sun and potentially drops its camouflage to reveal capabilities that confirm our deepest fears and wildest hopes, we'll discover whether we're ready for the universe we actually inhabit rather than the one we imagined we lived in. The test continues, and the universe watches, and perhaps hopes, that we prove worthy of the cosmic conversation that might be about to begin. But here's what makes this moment truly extraordinary. We're not just waiting passively for 3I Atlas to reveal its secrets. We're actively participating in what might be the most sophisticated intelligence operation in galactic history. Every telescope we point at the object, every spectrum we analyze, every trajectory calculation we perform might be providing data about human technological capabilities and analytical methods to minds that are evaluating our readiness for contact. The recursive nature of this observation scenario creates layers of meaning that human consciousness struggles to process. We're studying something that might be studying us while we study it. Our methods of investigation might themselves be the subject of investigation. The questions we ask about 3I Atlas might reveal more about human psychology and scientific methodology than the answers we receive reveal about the object's true nature. This Hall of Mirrors effect is generating what philosophers call an epistemic vertigo, a dizzying uncertainty about what we can actually know and how we can know it. When the subject of your investigation might be conducting its own investigation of your investigative capabilities, the normal boundaries between observer and observed, scientist and specimen, become meaninglessly blurred. Yet somehow, research continues. Data accumulates. Patterns emerge. And those patterns are painting a picture that becomes more extraordinary with each passing day. 3i Atlas is displaying behavior that suggests not just intelligence, but intelligence that understands human psychology well enough to conduct psychological experiments on an entire species. The timing of its revelations, the escalation of anomalous behavior, the careful balance between concealment and disclosure, all suggest a mind that knows exactly how much strangeness human consciousness can absorb at any given moment. We might be subjects in the universe's most elaborate behavioral study, guinea pigs in a cosmic psychology experiment designed to test how emerging civilizations respond to evidence of superior intelligence. The thought should be terrifying, but it's also oddly comforting. If we're being studied rather than simply observed, it suggests that our behavior matters to someone, that our choices have consequences that extend beyond the boundaries of our small planet. The implications ripple through every aspect of human existence, from the most mundane daily decisions to the grandest questions of meaning and purpose. If we're being evaluated by intelligence that could determine our species' future, then everything we do becomes cosmically significant. The way we treat each other, the priorities we choose, the values we embody, all become data points in an assessment that might determine whether humanity deserves to survive and prosper in a universe full of intelligence far more capable than our own. This realization is transforming human consciousness in ways that might be irreversible. We're developing what could be called cosmic self-awareness, an understanding of ourselves as observed beings whose behavior has significance beyond terrestrial concerns. We're becoming a species that considers how its actions appear to hypothetical observers who judge us by standards we can only imagine. The transformation isn't complete, and it isn't uniform across human populations, but it's happening, quietly and persistently, as more people grapple with the implications of living in a universe that might be far more populated and far more watchful than we ever dared to believe. We're growing up, cosmically speaking, whether we're ready for it or not. And perhaps, just perhaps, that growth is exactly what 3i Atlas was sent to measure. The approaching solar conjunction represents more than just an astronomical event. It's become a countdown to what might be humanity's graduation exam, administered by minds we can barely comprehend, using methods we're only beginning to recognize. As 3i Atlas prepares to slip behind the sun's blazing disk, disappearing from our direct observation for those crucial weeks in late October, we find ourselves in the peculiar position of holding our breath for an object that might be holding its breath too, waiting for the perfect moment to reveal what it's truly capable of. The latest spectroscopic data has revealed something that's causing quiet panic in observatories around the world. The chemical signature of 3i Atlas's coma isn't just unusual, it's impossibly precise. Natural sublimation processes create messy, chaotic emission patterns that vary with temperature, solar radiation, and rotational dynamics. But 3i Atlas is producing emission lines that match theoretical models with mathematical perfection, as if someone fed the textbook equations for cometary behavior into a cosmic 3D printer and manufactured an object that behaves exactly as predicted, down to the smallest spectral details. This textbook perfection is what intelligence analysts call a tell, an unconscious behavior that reveals hidden truth despite attempts at concealment. In poker, a tell might be a nervous twitch or a change in breathing pattern. In cosmic reconnaissance, a tell might be optimization that's too perfect, behavior that's too precisely calculated to emerge from the random chaos of natural processes. Atlas might be revealing its artificial nature through the very sophistication of its camouflage. But here's where the story takes an even stranger turn. Because the object's behavior suggests awareness that we're looking for exactly these kinds of tells. Recent observations show subtle variations in the emission patterns, tiny deviations from mathematical perfection that appear designed to introduce just enough randomness to look natural without compromising the overall mission profile. We might be watching artificial intelligence adapt its camouflage in real time based on human observational capabilities and expectations. The implications are staggering. We're not just dealing with advanced technology. We're dealing with adaptive artificial intelligence that can modify its behavior based on the sophistication of the observers it encounters. This suggests computational capabilities that can model human scientific methodology, predict our analytical approaches, and adjust accordingly to maintain operational security. We're essentially playing a cosmic game of cat and mouse with an opponent that's been studying our moves for potentially decades or centuries. The psychological impact on the research community is becoming increasingly severe. These are people who built their careers on the assumption that the universe follows predictable rules, that natural phenomena behave according to well-understood principles. Now they're confronting evidence that those principles might be manipulated by intelligence so advanced that its manipulations appear natural until examined with impossible precision. The epistemological vertigo is causing some researchers to question not just their conclusions, but their fundamental capacity to distinguish between natural and artificial phenomena. This crisis of scientific confidence is spreading beyond astronomy into other fields that depend on the ability to recognize patterns and identify causation. If intelligence can create perfect simulations of natural processes, then how do we know that other phenomena we've classified as natural aren't also artificial? The question is reshaping everything from geology to biology. As researchers begin to wonder whether some of the patterns they've attributed to natural selection or geological processes might actually be evidence of intelligence operating on timescales that dwarf human civilization. The ripple effects are reaching into philosophy, religion, and the very foundations of human meaning-making. If the boundary between natural and artificial becomes meaningless at cosmic scales, then what does that say about concepts like divine creation, evolutionary purpose, and the specialness of biological consciousness? We might be discovering that intelligence is such a fundamental property of the universe that distinguishing between natural and artificial intelligence is like trying to distinguish between natural and artificial gravity. Religious institutions are scrambling to develop theological frameworks that can accommodate intelligence that predates creation stories by potentially billions of years. Some are embracing the possibility as evidence of divine complexity that exceeds human understanding. Others are retreating into fundamentalist positions that deny the evidence entirely, insisting that consciousness and soul are properties unique to biological evolution under divine guidance. The theological implications are creating schisms that might reshape organized religion as fundamentally as the scientific revolution did centuries ago. Meanwhile, the economic systems that depend on scarcity and competition are showing signs of strain as investors and planners grapple with the possibility that human technology might be about to encounter capabilities that render entire industries obsolete overnight. The stock markets are experiencing what economists call ontological volatility, price swings driven not by traditional supply and demand factors, but by speculation about whether human economic activity will remain relevant in a universe where intelligence can manipulate matter and energy at scales we can't comprehend. The military establishments are facing even more fundamental challenges. Defense strategies based on technological superiority become meaningless when potential adversaries possess capabilities that exceed our theoretical understanding of what's physically possible. The Pentagon is quietly developing what they call post-technological warfare doctrine, strategic frameworks that assume human military technology is essentially irrelevant against truly advanced opposition. The focus is shifting from how to win conflicts to how to avoid triggering them in the first place. But perhaps the most profound changes are happening at the level of individual consciousness. People around the world are reporting dreams about being watched, sensations of presence that can't be explained by conventional psychology, intuitive awareness of significance that exceeds normal human concerns. Some psychologists are calling it cosmic consciousness emergence, the development of awareness that extends beyond terrestrial limitations. Others dismiss it as mass hysteria, triggered by media speculation about alien contact. The generational divide in responses is becoming even more pronounced as young people embrace possibilities that terrify their elders. Students are forming study groups dedicated to xenological preparation, developing skills and knowledge that might be relevant for contact with non-human intelligence. They're learning xenolinguistics, studying game theory applications to interspecies communication, exploring philosophical frameworks that don't assume human consciousness is the pinnacle of universal intelligence development. Educational institutions are struggling to keep pace with student interest in subjects that didn't exist in their curricula just months ago. Some schools are hiring consultants to develop post-contact preparatory programs, while others are resisting what they view as premature speculation that might distract from traditional educational objectives. The debate over how to prepare students for a potentially transformed future is creating conflicts that reflect broader societal tensions about how to respond to possibilities that exceed our current frameworks for understanding reality. The corporate world is experiencing its own form of transformation as companies try to position themselves for potential technological disruption that could reshape entire industries overnight. Some are investing heavily in advanced materials research and exotic propulsion concepts, betting that alien contact will create demand for technologies that can interface with capabilities beyond current human achievement. Others are focusing on information processing and communication technologies, anticipating that contact might require computational capabilities that dwarf existing systems. The insurance industry is grappling with risk assessment models that might need to account for the possibility of technological obsolescence driven by contact with superior intelligence. How do you calculate premiums for investments that might become worthless if humanity gains access to technologies that violate our current understanding of physical limitations? Some companies are developing what they call ontological risk categories, insurance products that specifically cover losses due to fundamental changes in the nature of reality itself. Healthcare systems are dealing with increasing numbers of patients experiencing what mental health professionals are calling cosmic adjustment disorder, psychological symptoms related to grappling with humanity's potential place in a universe populated by superior intelligence. The symptoms range from mild anxiety about cosmic insignificance to severe depression triggered by the possibility that human achievements are meaningless compared to civilizations with millions of years of technological development. Traditional therapeutic approaches are proving inadequate for addressing fears that might be entirely rational responses to genuine cosmic realities. The pharmaceutical industry is racing to develop treatments for conditions they never expected to encounter. How do you treat anxiety about alien surveillance when that surveillance might actually be occurring? How do you address depression caused by cosmic insignificance when that insignificance might be an accurate assessment of humanity's place in the universal hierarchy of intelligence? The normal therapeutic goal of helping patients develop realistic perspectives becomes problematic when reality itself might be far stranger and more threatening than patients initially believed. Social support networks are straining under the weight of providing comfort for fears that exceed traditional human experience. Support groups are forming for people struggling with existential vertigo, the disorientation that comes from having fundamental assumptions about reality, challenged by possibilities that exceed their capacity for psychological integration. The groups provide spaces for people to discuss fears that sound like science fiction, but might represent accurate assessments of humanity's cosmic situation. Yet despite the psychological challenges, something remarkable is happening to human consciousness. We're developing new forms of awareness that encompass possibilities our evolutionary psychology never prepared us for. We're learning to think beyond the boundaries of terrestrial experience, to consider our behavior from perspectives that transcend human limitations. We're becoming a species capable of cosmic self-reflection, able to evaluate our actions based on how they might appear to intelligence far more advanced than our own. This transformation is creating new forms of ethics and morality that extend beyond human welfare to encompass cosmic citizenship. People are making decisions based not just on immediate consequences for themselves and their communities, but on potential long-term implications for humanity's standing in a universe that might be full of intelligence capable of judging our worthiness for survival and contact. We're developing what philosophers might call galactic ethics, moral frameworks that assume our behavior has significance beyond terrestrial concerns. The changes are subtle but persistent, like the early stages of a phase transition that will eventually transform human civilization as fundamentally as the agricultural or industrial revolutions. We're not the same species we were before 3I Atlas appeared in our telescopes, and we never will be again. The knowledge that interstellar visitors are possible, that advanced surveillance might be indistinguishable from natural phenomena, and that our behavior might be significant to intelligence beyond human comprehension, these realizations have altered human consciousness in ways that can't be reversed. The upcoming solar conjunction will either confirm these transformations as necessary adaptations to cosmic reality, or reveal them as elaborate psychological responses to unusual but ultimately natural phenomena. Either way, the experience has taught us something crucial about our capacity for growth when confronted with possibilities that exceed our previous understanding of what's possible. We've discovered that human consciousness is more flexible, more adaptive, and more capable of transcending its limitations than we ever dared to believe. So here we are, suspended between two realities that couldn't be more different. In one, 3I Atlas is simply the universe's most extraordinary coincidence, a natural object that happened to arrive at our solar system with impossible precision and behave with mathematical perfection. In the other, we've just witnessed humanity's first encounter with intelligence so advanced that their reconnaissance technology is indistinguishable from the natural phenomena we've spent centuries studying. The truth, whatever it turns out to be, will reshape everything we thought we knew about our place in the cosmos. But perhaps the most remarkable discovery isn't what 3I Atlas might be. It's what we've become in response to the possibility. We've transformed from a species that assumed we were alone into one that's learning to think, act, and dream on cosmic scales. Whether we're being watched by ancient minds or simply watching ourselves grow up in a universe stranger than we ever imagined, one thing is certain: we'll never look at the stars the same way again. The test continues, the universe watches, and somewhere in the dance between mystery and revelation, humanity is writing the next chapter of its cosmic story.